Diagonal of a square computer screen is 50 inches. What is the perimeter of this screen?
Sounds like a me question.
A you question.
All right, so this is kind of a an interesting question. One of the things that I always used to think when I would buy a TV or a monitor is I always thought I was getting ripped off because they'd be like, oh, it's a 20-inch TV, and then you would measure it, and like none of the dimensions are 20. And the reason why companies do that, first of all, we said this before I get sidetracked. That's 50 inches, and that's my TV. The reason why companies do that is because all TVs, well, a lot of TVs have different dimensions. And so this is a uniform way for them to all kind of give one dimension. Like, I don't know if you've noticed, but like TVs have gotten wider and shorter to make up for that kind of wide screen that shows more of what's happening in a movie. So the reason why computer, monitor, and TV manufacturers label it this way is so everybody can be talking about the same measurement, right? Because you don't want a TV that's like really wide, but really short to sound like it's bigger than a TV that's narrower and a little bit taller.
It considers both length and width.
Exactly. Yeah. So there are actually a couple ways to do that. We wanted the perimeter, right? So we want to know this, and it's a square. So
Did it
this
say
kind of, yeah, square monitor, right?
Yes, it is a
Square.
square.
Oh, square.
And
I'm
that's
sorry, I'm
actually a
questioning
really
you.
important thing to note. So we said square monitor. I'm going to kind of point out why I kind of latched onto this word, because without it, you would not be able to figure out the perimeter. So,
That's true.
or at least not in a very difficult way. Maybe there is a way that I'm not thinking of right now. But right now, if we were to look at this, we have dimensions like X and Y. In order to find the perimeter, you need to find the values of the length and width and add them together. The problem with this, if it didn't specify that this was square, is that you'd have two different measurements, and it's exactly like what Becca just did. If we had two measurements and we only have one equation we can set up, then we're not going to be able to solve it. So we need to relate them to each other. So in this case, we do have like length and width, but we also know that they're the same. So instead of calling this y, we're going to call it x. Again, as much as you can, anytime you're doing algebra, geometry, anything math, the more that you can relate your unknowns to this same one variable, the easier it becomes and the more likely you are to see the solution. If I had two variables here, you're going to see we're going to be doing Pythagorean theorem, and you would have too many variables to solve for in one equation. So in this case, we have a square monitor. So we know all the angles in a square are 90 degrees, or right angles. So what we're going to do is use Pythagorean theorem. Remember, Pythagorean theorem says that in a right triangle, the legs squared added together equal the hypotenuse squared, or the other way to think about that is this old thing that you probably heard a lot of times, a squared plus b squared is c squared, where it's really important to note that c is always the hypotenuse. So all we're going to do now is plug in our variables. So I have x here. I'm going to plug in an x here. We got another x here for my b, so I'm going to plug in another x right here. And then I'm going to be left with x squared plus x squared equals 50 squared. So now, again, we have one equation, one variable. We can solve it because we related them. So x squared plus x squared is going to be 2x squared equals, and then 50 squared. If you aren't familiar with this trick, instead of using your calculator, what I do is I just do 5 times 5, and I get 25. And then I've got a 0 here. So because I'm squaring it, I'm going to throw 2 zeros on the end. If I were cubing it, I would throw 3 zeros on the end. So we're going to get equals 2,500. And then we're going to divide by 2, x squared equals 1,250. And now I probably need a calculator as I square both sides. So x equals the square root of 1,250. Now, Becca's doing this on the calculator. for these application problems, I want you to consider whatever we get here has to be less than 50. If it's more, we made a mistake. All right. So we got 35.35 inches, which I'm just going to round to 35.3 inches. 6.
Yeah.
Wait, 35.4. I'm just going to round it
Yeah.
to this. So that's a length of 1. All the sides are the same because this is 35.4. And this is 35.4. We have a square. We could add 35.4 4 times, or we can use what we know about multiplication and do 35.4 times 4, which equals 141.4 inches around. So that's how you would do this. A lot of these problems, when you see squares and diagonals, things like that, I always look for some sort of right triangle. Almost any time you have a square and you're solving for some missing side, you're often going to have some right triangle in there if you're cutting something.
Pythagorean theorem. It's
Very useful.
probably, yeah, I was going to say, it's probably one of the most useful things I learned in geometry that
Right.
applies to real life. I mean, the most often, so
Yeah.
worth it.